Hi, this is King of Review. Here we're asked to find the nth term an of the sequence 3, 4, 6, 10, 18, etc., all the way up to an, the nth term. To find a pattern in a sequence, I like starting by seeing how you get from one term to the next. From 3 to 4 we add 1. From 4 to 6 we add 2. From 6 to 10 we add 4. From 10 to 18 we add 8. Now here I'm starting to notice a definite pattern in these numbers we're adding. Every time you go from one to the next, you multiply by 2. And since you multiply by the same number each time, these numbers constitute what's called a geometric series because you multiply by the same number. That number is called r, the common ratio, and in this case, it's 2. Every single time you multiply by 2. Since it's geometric, since we're multiplying, we can write these numbers as powers of 2. 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4, 2 cubed is 8, and so on. So now that we've sort of figured out the underlying pattern in this sequence, let's return to an, the nth term. This sequence starts at 3, and we know if we want to get all the way to the nth term, we have to add all of these numbers up. 1, and 2, and 4, and 8, and so on, all the way up to something. We're going to have to figure out where we stop to get the nth term. And to figure that out, let's rewrite these numbers in terms of their exponents. 2 to the 0, 2 to the first, 2 to the second, 2 to the third, and so on. Now, we know we're stopping at the nth term, but since we started with an exponent of 0, the final term isn't going to have an exponent of n, it's going to be n minus 1, since we started with 0 rather than 1. Well, to simplify this expression, let's look at this series. As we said, this is a geometric series, and geometric series have a nice formula for the sum. It looks like this: a times 1 minus r to the n over 1 minus r. A, in this case, is the first term in the series. The first term in our series is 2 to the 0, which is 1. So I'll have 3 plus, and then in this fraction, this sum formula, 1 times. Now I need 1 minus r to the n. 1 minus r we decided was 2, and n in this formula means the number of terms, the final number. So in this case that's n minus 1. 2 to the n minus 1. And then on the bottom we have 1 minus r, 1 minus 2. So this is 3 plus, multiplying the top by 1 gives us 1 minus 2 to the n minus 1. In the denominator we have 1 minus 2, which is negative 1. Dividing the top by negative 1 switches the sign, so we get 3 minus 1 plus 2 to the n minus 1. And if we rearrange this a little, we see that it equals 2 to the n minus 1 plus 2. So our answer is D. And that's it. Thanks for watching.